All right, so look, it's almost the same thing as before, except this time, what's different? Well, okay, well, not just the letters, but like they didn't put anything in the diagram, right? You know how the other problem you had, yeah, markings on the diagram? What I want you to do is take the stuff that's given to you, and mark it into the diagram. Angle B is congruent to angle L. I could put an arc there and an arc there, and just to keep it consistent with the other problem, we could put a little tick in between them, right? So any angle with a tick is congruent to any other angle with a tick. Let's mark the other given first. Let's do this one. Angle BAE, so that's B to A to E, so that's this corner. I'm going to put a double tick this time. Is congruent to angle LAE. So L to A to E, that is this angle. And I'm going to put a double tick. Do you see a side that's being shared between both of the triangles? Isn't AE being shared between both of them? So AE belongs to this triangle, and AE also belongs to that triangle, right? Aren't they the same length then? Because they're the same side? So what we could say is that AE in the blue triangle is congruent to AE in the black triangle. So we put that little squiggly X. And there's a name for that. This is called the reflexive, right? Not reflect, reflects with an X. Reflexive property. So now guess what? We have everything written. Which postulate would prove that the two triangles are congruent? Yeah, AAS. Do you guys agree with that? Angle, angle, side? Because the side is not in between the two angles. So you understand that in this triangle, you have an angle here congruent to an angle there. You have an angle here congruent to an angle there. And there's something missing, right? Like angle is not enough. And yes, this side right in the middle, this side right here, is shared between this triangle and that triangle. They're sharing that one side. So, but if it's the same side, that means that this side for this triangle, this side for that triangle have the same length. So basically, I'm saying that this is the side that we could use. Right? Like if I were to split the triangles apart, we have angle, angle, side. All right, so we know for sure that we're going to prove that it's congruent by angle, angle, side. And that's it. Then it becomes just like the problem that we did before. So the thing that you have to prove is going to be a last statement. Triangle BAE is congruent to triangle LAE. Why? Angle, angle, side. But now you have to prove each of those pieces, right? And for one angle, notice the direction I'm writing the arrow in as well. For one angle, they gave it to us. Angle B is congruent to angle L. Why could I say that? Because it's given. You have to write this down. Okay. All right. For the other angle, it was given as well. It's right here. They literally told us. Angle BAE is congruent to angle LAE. Why? Because it was given. But what about the side? AE is congruent to itself because AE belongs to both triangles. Why do we know that they're congruent? Because they're the same side, right? Isn't anything congruent to itself in length, right? So, but you don't say that. The reason you give is reflexive property. So the reason is the reflexive property. And you're done. I literally proved these two angles are congruent, and this side is congruent, so the triangle is congruent by angle side. The thing is, this triangle is like sideways. The angles might be different. It might be angle side angle this time. It might be, or it might just be angle side, or something along those lines. But basically, UY is a reflexive property, right? That's the side that's being shared between both triangles. UI. So like one of the things I would do is just put like a little X, a squiggly X over it to show that that side is congruent to itself in both of them. AAS, I think it's ASA, but let me just mark it in. SUY is this angle. And NUY is that angle, right? So these two angles are congruent. SYU, S to Y to U is this angle up here. And NYU is this one over here. Okay, so you have this angle, you have the side, and you have that angle. Is the side in between the two angles? Yes. Yeah, so it is ASA. The two triangles are congruent by ASA, but you have to prove it. And I hope that that part is easy, because literally the two angles are given. The hard part is actually figuring out which one it is. Well, okay, so you have to prove three things, right? You have to prove an angle, a side, and an angle. And the two angle statements were given, right? Like those were the given ones. So I'm just going to write that. Angle SUY is congruent to angle NUY. We know this is true because it was given to us. The side is UY is congruent to itself. And we know that's true because that's the reflexive property. And then the last angle set is this one. It was given to us. Angle SYU is congruent to angle NYU because it was given. It's easy when things are given. And there you go. They actually marked it in the diagram. This one, they marked it a little bit differently. Usually we had two ticks before, but instead it just put two arcs. You have to prove triangle LMO, so that's this one over here, is congruent to triangle NOM, which is this one over here. Well, what's the side that they share? MO, right? Like this is the piece. That's a side that they both share. So which postulate would it be? Here. Congruent to that angle. Yep, you have an angle here, congruent to that angle. And the side is not in between the two angles. Right? I'm like, focus on only this one. Right? You have angle, and the side is not in between the two angles. It's angle, side. All right, so go ahead, write out the proof.
Rock and roll.